Does he have access to their medical records? I think one of the greatest things about
Canada
is the computerization of medical records.
According to the Canadian Patient Safety Institute, there are about 28,000 yearly deaths due to medical errors, such as incorrect prescription doses or overlooking a known allergy. With institutions still transferring hard copies of medical data, transfer of vital information can not only be expensive, but time-consuming. It is clear an alternative is needed to our current medical storage solutions. Our solution to the medical storage problem is MedNet, a blockchain-based solution used to securely transfer and receive data between patients, doctors, hospitals, and pharmacists. MedNet ensures user privacy and security by implementing two-factor authentication, requiring a patient to not only register their password, but scan and confirm their fingerprint to access sensitive data. Additionally, MedNet uses blockchain, a highly secure and cutting-edge storage solution to ensure your medical records are stored with a high degree of security.
Let's do a quick demonstration of our product MedNet. Here, I am enrolling a new patient onto MedNet by signing up using personal information, a unique personal health number, a keyword, and a password. The patient will finish registering by scanning their fingerprint using the fingerprint module.
When the user clicks Register with Fingerprint, a Python script is invoked on the client computer to which the fingerprint scanner is connected to. This eliminates a green light on the optical fingerprint scanner, indicating it's ready for a fingerprint scan. The user gives their biometrics by placing their finger on the fingerprint scanner. Then the light reflected will be obtained by the sensor, which then reconstructs the image. A Python script, which is run on the client side, then converts this image into a hexadecimal byte array. This byte array is then transmitted to the backend AWS server using WebSockets.
What is a networking socket? To put it simply, networking sockets allow data to be transferred from one computer to another by establishing a connection between the two. MedNet uses a client-server model. This means there's a service set up on our computer, which listens for incoming messages, and a client on MedNet's backend to initiate connections to these various servers. To achieve this, we use the TCP Internet Protocol.
When this button is clicked, the fingerprint sensor activates and is ready to collect data. Let's log into MedNet as a doctor by inputting a unique medical identification number, keyword, and a password. Let's perform a patient lookup for the new patient we just created using their personal health number. We can see that no patient records exist. Let's add a new doctor's note for this patient. This information will be attached to the patient's PHN and encrypted when stored in the database like so. Let's look up an existing patient who is visiting this particular doctor for the first time. In order to know the patient's medical history, the new doctor needs to request access to view their past records. The patient will enter their keyword and authorize by scanning their fingerprint using the module.
After the backend receives the fingerprint from the client, this byte array is converted back into an image, and fingerprint image of the corresponding patient is retrieved from the database. Then an algorithm written in C# extracts fingerprint features and computes a confidence score. If the confidence score is above a certain number, a signal is sent to the website giving the doctor permission to view patient's medical records.
As the patient's fingerprint matched with a high confidence score, the doctor is granted access and the patient profile is populated with patient's past records.
Blockchain is a solution that stores copies of the data over a network of computers, which makes it a distributed system. Since these computers can be owned by different organizations or companies, it makes it hard for any one organization to create a complete monopoly over the medical data of the people. Hence, it is decentralized. The network of computers contains copies of the entire database. Therefore, if one computer is made unavailable, then other computers can provide the same data, making the system fault tolerant. The transactions in the database are transparent and easily verified using cryptography. We are using BigchainDB as a blockchain storage solution where we'll be storing our user profiles and medical records. BigchainDB uses MongoDB as its underlying storage database. That means each computer part of the BigchainDB network has its own instance of MongoDB. BigchainDB also uses Tendermint consensus protocol that acts as the communication backbone between the multiple computers of the BigchainDB network. Here we can see the 5 virtual computers that are part of our BigchainDB network. While initially we wanted to make a network of physical computers, due to the COVID-19 pandemic, we decided it was more practical to use virtual computers hosted on Amazon Web Services for development and demo purposes. It is important to note that having virtual or real computers does not affect the working of MedNet in any significant way. Here I am asking each of the computers to show the various computers that they are currently connected to. As we can see, each computer is connected to the other 4 computers. Now I will stop the BigChainDB services running on any one of the computers. And then I will ask the other computers to show the currently connected computers again. As we can see, now the computers are only connected to the remaining 3 computers. Finally, I have directly connected to the underlying MongoDB databases of the 5 computers. And as we can see, they're all identical and store copies of data.
The server is hosted on an Amazon Web Services virtual machine and implemented using the ASP.NET Core framework. These 2 services are used to communicate with the client browser user interface and securely transfers information via HTTPS.
In summary, MedNet has 4 main components: a blockchain database, a web application, a computer to access the web application, and a fingerprint module with a USB to TTL converter. As seen in the table, we are able to minimize project costs by using the free tier of Amazon's EC2 instances for both the blockchain database and our web application. However, we did pay a hefty fee of $2 to reserve our domain name, lifeblocks.site, and a $50 fee for the fingerprint module with USB to TTL converter. This brings our total project cost to a whopping $52. To satisfy our cradle-to-cradle design constraints, we chose the various components with the intent for them to be reused. More specifically, our EC2 instance will be released upon project completion. Our domain name will be released in a year's time. Our fingerprint module will be repurposed for other projects. And our knowledge learned will be used for our future endeavors.